everybody, welcome to today's video cast webinar on mastering the National Electrical Code. My name is Paul Abernathy and I'm going to be your presenter today on behalf of Electrical Code Academy Incorporated. Before we get started, I will encourage you to visit the website at www.electricalcodeacademy.com, but it is also available on .net and .org. And there's a message board, there's Twitter accounts, and a Facebook that you can join in, ask your questions, excuse me, and chime in on any code changes, anything you'd like to add, questions you'd like to bring to ECA, and all of those type of things are available from the websites. You can also email us at any time at info, that's INFO, at electricalcodeacademy.com. You can also email us at info@masterthenec.com as well. All right, so today's webinar or video cast is going to be on changes to the 2017 National Electrical Code. More specifically, we're going to talk about Article 250, grounding and bonding. Now, there have been significant changes throughout the code development process for the 2017 NEC. We're all getting used to the different changes that started in 2014 edition, whereas we have this public input, public comment, first revision, first draft, second draft, NITMAMs, and what have you, in order to get us to where we are today, which is the publishing of the 2017 edition of the National Electrical Code. All code making panels worked very diligently with all of the public inputs, public comments, in order to try to put together the best code that they can. An effort was achieved as it finally was sent off to NFPA for approval and subsequently publishing of the document. Again, the code is a constantly evolving document, so we encourage everybody out there to get involved. This is your document. This isn't published by the NFPA, it's their document. They're simply the facilitator of a code that all of the people, the stakeholders, have to be able to participate in order to get the development. So if you put in your public inputs, public comments, and you played a part in it, congratulations to you. It is finally to print. But in today's episode, we're going to talk about significantly certain changes that took place in Article 250, dealing with grounding and bonding. There were quite a few significant changes. There were some changes that were simply text and oriented, and we probably won't cover all of those changes today. We're going to focus on what we feel is the more significant. And of course, as always, our guide that we're going to use is the changes that are published by the IAEI, which we strongly support their effort, and we encourage you to purchase the analysis of change by IAEI to support that organization. We also support NFPA in your purchasing of code books directly from that association. It helps fund ongoing safety measures to protect people like you and me from the effects and safeguards of the use of electricity. So, with that all out of the way, we are going to use the National Electrical Code book today to look at some of these references. We're not going to be overly laden with graphics because, in fact, we're not going to use any. We're going to use the code book. I use the PDF version. It is licensed to me simply because we want to make sure that we discuss the code and we don't have any personal opinions involved in it. While I might interject during the webinar certain things, really we're trying to stay pure to code. And again, understanding that your jurisdiction, whether you're an inspector, whether or not you're a military body who has to have an AHJ assigned, usually it's the staff who's ahead of that base, or whatever facility, if you feel like it's a governmental facility, there still has to be an AHJ. So if you adopt the governing body or the governing document of the NFPA, somebody has to be that AHJ. So for the electricians, this is going to be great information to help keep you abreast of what's changed in Article 250. We obviously have other webinars and other episodes on the other articles within 2017 changes, but this one's focusing specifically on those that are in Article 250. All right, I have some extensive notes that I have been taking as I went through 250. So I have some things I'll discuss with you as we go through it. Again, if you have any questions on any of these changes or you want more detail into these changes, by all means, feel free to email us here again at info@electricalcodeacademy.com, and be more than happy to answer your questions. Or if it's easier for you, just go to our message board, log in and get an account, and put your question on the message board under the code forum section, and we'll be more than happy to openly answer your questions to any of these changes if there's any clarification that's needed after this presentation. I'll also remind you that this presentation is being recorded, so it will be available in the future on our YouTube account, which is also accessible from our website, www.electricalcodeacademy.com. So if you ever need to watch it again or want a refresher, you can always go there. All right, so let's get started. What I'm going to do is I'm going to bring up the National Electrical Code, and we're going to kind of go through each one of these that I feel is more significant, and I'll talk about it. I'm going to remove me from the screen, so there's no sense in watching me. It kind of helps you focus on the code, because I recognize that a lot of people might not have their code book yet. So I do, and I want to be able to share that with you in order to look at each one of these changes. All right, so let us get started. The first change that we're going to look at is we're going to go to 250.22 item 6. So let me go down to that one. And hopefully you've got everything on the screen. So what we're dealing with in 250.22, the charge rule here is circuits not to be grounded. That's what we're dealing with. Now, it's important to realize that in Article 250 you have a structure which is divided into three categories. One that you have in 250.20 is where AC systems are required to be grounded. We have that takes place. All right. We also have to remember that there's a item 2 that says, hey, wait a minute, AC system 50 volts to 1,000 volts that are not required to be grounded. However, you may ground them, but they're not required to be grounded, and that is covered in 250.21. Then you have those systems that are prohibited from being grounded, and that is what we have in 250.22, and that's what we're dealing with here. So in the 2014 edition, you had 5 items that covered specific areas in the code that was specific in the fact that they were not to be grounded. Okay? They were not intentionally grounded in their installation practice. Well, in 2014, we created this new article, 393. And this new article really dealt with ceiling power distribution systems that were low voltage design. And that got a lot of prominence in the 2014 as one of the new articles. But the nature of those are class 2 circuits on the secondary side of a transformer that creates this class 2 low voltage system and this low voltage grid distribution system, which can be used for a multitude of things. Whether it's office areas, in order to power computers, whatever it's needed where you didn't need it or didn't be grounded. Didn't need it to be connected to a grounded conductor application. All right. So in this case, it doesn't need to be grounded, and all the code did here was add an item 6 to 250.22 for circuits not to be grounded with the addition of now class 2 load side circuits for suspended ceiling low voltage power grid distribution systems. Okay, and it expresses that in more detail in 393.60b. So that was the change that took place for the 2017 when it came to just adding another circuit that is not to be grounded. All right, so that was your significant change in that one. The next change that we're going to look at is going to be in 250.30 A4 and 5. So let's take our code book and let's go down to those areas of change. And let's see here. Gotta bear with me because let me make this smaller so we can see it all there. All right, so we're looking at 250.30, and there's 32. So You know, I always said it would be easier to use the electronic version, but it is not, I can tell you right now. All right, so here, grounding separately derived alternating current systems. There has been a change in this application. Now, one of the significant changes here is the use of metal water piping or building steel as the first option previously when you have to have a separately derived system and you have to connect it to the grounding system. Those were the steps that had to take place. All right, in the previous code, that's what you had to do. You had to, in order to establish a grounding electrode system for this separately derived system, in the 2014 code, it said that you had to go to the nearest of either the metal water piping ground, as identified in 250.52a1, or to a structural metal frame of the building or structure, described in 250.52a2. They had to be utilized, and they had to be the nearest one, and that was what you choose. Nearest, as near as practical, is preferably in the same area. Language was in there. Well, for the 2017 edition, and I will scroll down to the changes here. You'll notice the changes here in gray text. It's in the 2017, any of the building or structure grounding electrodes that are present can now be used. It doesn't have to meet the 1 and 2 previously when it said, okay, you have to go to the water pipe or the structural steel, whichever's closer, whichever is nearer to you. And then if these two were not available, then you could use the others allowed within the code. All right? But you had to use these two first. Well, that was removed, and basically it says the building or structural grounding electrode system shall be used as the grounding electrode for the separately derived system, period. So you no longer have item 1 and item 2, which were grounding electrodes the way they stated it, and then they had to be used. The significance also here is it did reiterate that the water piping and the structural steel framing, as covered in 250.68c1 and 2, they're being recognized, and they were in the previous code, they're being recognized as conductors to actually extend that grounding electrode connection. Okay? Not necessarily the electrode. For example, water piping is within 5 feet of point of entry. That is part of the electrode. But now it's saying that as it extends through the building, it can actually extend that connection, and that's covered in 250.68c1 and 2. Okay? So nothing really changed there. They do extend that. But at this point, there isn't any hierarchy. Basically, if I have a separately derived system in that building or that structure, I need to go to the whatever grounding electrode system that is in that building shall be used. Okay? So that was a significant change when you're dealing with that there. The other part that I think is really important to remember is this part here that was added in item 5. When it says that it shall be used to connect the grounding, the grounded conductor to the derived system in the grounding electrode as in accordance with 250.30a4. We get that. But it says, or as permitted in 250.68c1 or c2. And that is saying that those two items, which is the water piping, the metal water piping, and the structural metal framing, as covered in 250.68c1 and c, can be recognized as conductors to extend that connection to the grounding electrode. Okay, so they're basically saying they can be used as conductors. All right? And of course, you have to meet all the requirements in 250.68c1 and 2 to do this, but it is putting that language in place for you to be able to establish that. So that was a significant change there. Really, to me, it just allowed you to use, you have to use the electrodes that are available. It doesn't create this issue with a separately derived system where you have to go to the water pipe or you have to go to the structural steel, and they have to be the nearest. The nearest part has been removed. So it really has no role on it, how far it is. Okay? So the nearest portion that was in that previous text has been removed. All right? So the next one we're going to look at is 250.30a6a. Okay? And in that application here, let me get to it. A6a is dealing with the common grounding electrode conductor. All right, so let's kind of do a little background here. This is a new revision, some new language, and a revision to an existing text. Now, in the 2014 code, when we say common grounding electrode conductor, we understand that if we have multiple separately derived systems, that we could run a single, in the past, we could run a single conductor, size not smaller than 3/0 copper or 250 kc mil aluminum, and then we could have connections, taps if you will, to that common grounding electrode conductor. Now that was pretty common. We saw that in high rises and facilitate the connection of multiple separately derived systems. Well, in the 2014 code, it stated, this common grounding electrode for multiple separately derived systems was permitted to be either the following. One, it could be the wire type, like we said, not smaller than 3/0 copper or 250 kc mil aluminum. That stayed. And it also said, or the metal frame of a building or structure that conforms to 250.52a, which ironically is an electrode. And at this point, we've established that 250.68 is going to take care of that as far as extending now the electrode. So it really isn't an issue of the metal frame being the electrode anymore, it's that extension. And the next item that it had in 2014 said, or the metal frame of a building or structure that is connected by a bonding jumper, not smaller again than 3/0 copper or 250 kc mil, to the grounding electrode. So if it didn't have a concrete encased electrode, but it was the building frame, and it jumped over to the grounding electrode system that was established, and it was 3/0 copper or 250 kc mil of aluminum, then you were okay. In the 2017, they kind of added it, numbered it, they itemized it a little bit better and said, look, and metal water piping that complies with 250.68C1 now, which again is an extension or being considered a conductor, as long as it complies with all of the allowances of 250.68C1, was actually added to the allowable methods for a common grounding electrode conductor for multiple separately derived systems. So that's what was added. And the revision also made for the metal structural frame of a building or structure to qualify as a common grounding electrode for multiple separately derived systems. So they spelled it out, itemized it out a little better, and made it clear. The 2017 NEC, along with those revisions to metal structural frame of a building, which was, if you actually look back, and let me see if I can go back here into this aspect here, it's the common grounding electrode conductor shall be permitted to be one of the following. And you see that it recognizes the metal water pipe that qualifies here. We're not so much talking about the electrode, we're talking about a metal water pipe that actually can extend that connection as described in 250.68C1. So you need to go look at that change if you're unfamiliar with this application. Now this came in 2014, so this isn't necessarily a new change for that aspect of it. And then again, the metal structural frame of a building or structure that complies with 250.68C2 or is connected to the grounding electrode system by a conductor not smaller than 3/0. So that portion of it did not change. Okay, it just added a little bit of a better list to it and added that water pipe in there as a viable means provided it meets the requirements of 250.68C1. All right. So that is your change for 250.30A6A. If I'm an electrician, what I take away from this change is that now in a high-rise building or multi-story building where I have multiple separately derived systems, I can run a common wire like I always did before, that is, as long as it is 3/0 copper or 250 kc mil aluminum or larger, and I can take my taps to it in order to be able to make that connection to the grounded point on those separately derived systems, where the main bonding jumper is, of course, where the system bonding jumper is, of course. But now I can utilize a metal water pipe for this application, and I have a little more clarity on the structural steel. It's not so much about the portion in 250.52 about in the earth, it's about the extension of that metal structural frame as an actual conductor. Okay? And that's what we're talking about here. I think the code making panels did a great job on that. I have no problem with that as long as the framing of the building qualifies and the inspector can verify that. No problem at all. The water pipe system as well, no problem with that as long as they can verify it and inspect it and prove to the authority having jurisdiction that it is complete and intact, then that is capable of doing so. All right. Again, the revision code reference in 250.68c2 that was added, that relates to, again, the metal structural frame of a building or structure being used as a conductor to actually interconnect the different electrodes as part of the grounding electrode system, not so much as the electrode itself. Okay. All right, the next change that we're going to look at is dealing with what we just talked about, the structural metal in the ground support of structures to be utilized as a grounding electrode. And so that one's going to be the change that takes place to 250.52a2. So let's go to 250.52a2. If you have your code books, you can follow. If you'll purchase the new ones, they might have already been shipped by now. I have no idea. I know that I'm on a code making panel, two of them, 5 and 17, and we have a PDF version. And again, this is a free webinar. I'm not being paid for this information, so I'm providing it for educational purposes only and for clarity. All right, so here's our change. First thing I will tell you, if you're new to the 2017 NEC, you'll see this little N here in the center portion, or it could be out here as well. That lets you know there's something new that was added. All right. So in this case right here, we're talking about grounding electrodes. 250.52a was dealing with electrodes permitted for grounding. A1 is metal underground water pipe. Okay, and we know that one. But you see here they added metal in-ground support structures. And this is all new information. Basically what it's saying, and again, remember, we're dealing with something that's potentially different than what's a concrete encased electrode application. All right? What is a metal in-ground supporting structure? One or more metal in-ground supporting structures in direct contact with the earth vertically for 10 feet or more, with or without concrete encasement. All right, so the title of metal frames of buildings, grounding electrodes, has been renamed. That was here before. Dealing with the metal frames of buildings has been renamed to metal in-ground support structures. Okay, that is what changed here. And it doesn't matter whether they're in concrete or not, or they're driven piles, steel piles, whatever that's been driven down. You know, the application here, based on how it's defined, is the structural metal member of a building or structure needed to be the conducting object with direct contact with the earth. Okay, so maybe the pilings or similar objects that are actually driven into earth, or maybe there's a hole that is bored into the earth and you have a structural supporting member that is actually put down in the earth in direct contact with the earth. That's what we're talking about, a metal in-ground support structure. All right. Now, typically in a metal frame of a building, this is usually above the ground, right? It comes to the pad, and in the past it could be connected with some J-bolts or whatnot to possibly a concrete encased electrode, which we have down here, and it makes the connection. This right here is talking about the metal of the building, the in-ground supporting structure that has to be done. Okay? All right, so that is your change here for the 2017 code. Now, it does say of multiple metal in-ground support structures. Now here, don't confuse this with the concrete encased electrode. This is an in-ground supporting structure, like a piling or a post that's driven or cored down in order to provide support for the structure, and it is in direct contact with the earth, and it is metal. All right? Now, just to remind you, because sometimes people want clarity on this, it shall be permissible to bond only one of the in-ground, one into the grounding electrode system. Not every one of them. You still add the 10 feet vertically or more, but it is, and it doesn't matter whether concrete is in there or not, whether it's encased or not, If this is like a support piling that's driven down and it's steel, then that can be utilized. Okay. The importance of this is to remember that we just talked about the building framing. That can be utilized when that connection is made to extend, all right? To extend that connection to the grounding electrode system, or treated like a conductor in 250-68 C1 and 2, okay? Whether we're dealing with a water pipe or we're dealing with this type of application here, all right? It also goes on to add an informational note that says, look, metal in-ground support structures include, but are not limited to, pilings, castings, or other structural metal that can meet this requirement here. Okay, so it adds a little bit of clarity to previously when people called it the metal frame of a building, and there was a lot of arguments what would constitute that. Okay. All right, hopefully if you have any questions, because for brevity and time, I want to make sure we cover all of these as possible. I cannot tell you how long this webinar will last. It could be an hour, could be 2 hours, but we will get through as many of these as we feel we can. And hopefully you're taking notes and writing these different sections down so that you can review them at your leisure, or watch this video at another time, just kind of introducing some new things. Incidentally, I do get questions from time to time. Since this says new, how come none of this is underlined? It's because the underlined content is from a change. This tells us that this is all new information, the way it's been restructured. Okay, so that's what the in here. That you're not going to see this underlined because or highlighted, because this was kind of given misleading representation that it was a change from the previous cycle. This means it's new material, so it's good to know. All right, next let's go to 250.52b3, and let's go to that. And I went a little too far. Bear with me, it's electronic version. I have to go a little slow. All right, so we're at 2B. Well, that was A. Excuse me. Here we go. B3. All right, so what was added here? Now, this is a list of what is not permitted for use as a grounding electrode. Now, we're very familiar with 1 and 2. The first one was metal underground gas piping. Okay, it has nothing to do with bonding the gas lines inside the building. Has nothing to do with this. Has everything to do with using a gas line or gas piping as an electrode. There's a difference between bonding to the gas system and actually using it in the ground as an electrode. I'm sure we all understand that. That's been hammered home to us for many years in that application, right? All right, so the next one was aluminum. Aluminum is very anti-corrosive. It forms a protective layer. However, we do not have the application where we use it as an electrode in the earth. You can use it as a grounding electrode conductor. You can use it for different types of taps. You can use it for equipment grounding conductors. You can use it as bonding jumpers and different applications, but it is not to be used as an electrode in the earth. Okay? All right, so what was added here? The change for 2017 was that it said the structures or structural reinforcing steel described in 680.26b1, which is a conductive pull shell, and b2, which is the perimeter requirement for the equipotential bonding grid, those cannot be used as grounding electrodes for a structure, whether it's a detached structure or whether or not it's the actual de facto structure itself, like the dwelling or the building or whatnot. Okay? And so this change here is prohibiting this area around the pool or the metal framing from being used as a grounding electrode in any application. It has a separate purpose. It is for equipotential bonding. It's to create voltage gradients. It is for a specific application that has nothing to do with the grounding electrodes that are required at buildings, which is what we're dealing with. Okay? So, many people believe that if you did do this with the pool, that you create a hypersensitive target for any type of stray currents that could be traveling through the earth, which are on the earth at any given time, or in the system that could produce a safety hazard to the occupants of that pool by interconnecting these systems directly in that nature. Okay? So, That is what we're dealing with here. So the 2017 NEC language added this in 250.52b, and it prohibits the use. Now, I'm not aware of anybody that did it. I do know that I have talked with some individuals that are pretty knowledgeable in this beyond me when it comes to the research that was done, and they think this is a lot to do with nothing. But again, code being what it is, it's still making clarity that you cannot do this. Again, the equipotential bonding requirements of 680.26 are to reduce voltage gradients. Okay, the key is to reduce the differences of voltage between two conductive objects. Okay, two difference of voltage potential. That's what we're trying to deal with when we're doing an equipotential bonding. Nothing to do to create a grounding electrode system for a building or structure. Okay, so that's what takes place here. Another important aspect of this to understand is that 680.26b1 and b2 are specific to Article 680, which can change and augment, supplement chapters 1 through 4. But in the case in here, Code Making Panel 5 determined that it was never the intent of the NEC to use anything to do with the bonding grid as a grounding electrode. And that was discussed during Code Making 5's discussion during the development of this section change. And so incidentally on this, I will note that this is a totally new application here that was added, which is item 3 of 250.52b. So look that over. I don't know of anybody that did this application, but in case you did, you are no longer going to be able to do it. All right, hopefully that was, yeah, again, this doesn't relieve you of your requirements in 680. Please don't forget that requirement. And also it does remind you, I talked about the gas piping, the informational note didn't change here, but it reminds you of bonding of gas piping, which is what I talked about or alluded to earlier. It doesn't remove you from that. We're strictly talking about what is prohibited from being used as electrodes in this application. All right, the next change is to 250.66, a much awaited change because of the confusion that it caused. For years, many people argued, what in the world was a sole connection? What did it mean? What was, I mean, I think it was pretty obvious to many people. The word sole connection has been in the code since 1965, but it caused a lot of confusion. I can tell you right now, I have answered many a question through the years about sole connections. My intent always was that it's a sole connection to that electrode. If it goes on to an additional electrode that would require a larger size, then that was no longer the sole electrode connection. All right? So with that daisy chain approach, they have changed that for the 2017 code to make it a little easier to understand, and I think they did a good job. So let's kind of look at it. The intent here of this change, which was a revision, is that the term sole connection for sizing grounding electroconductors to specific grounding electrodes has been removed and it has been revised. And it also made it real clear. Now, for years I had people that said, look, if I go to an application where I have ground rods involved, and I only have ground rods, maybe I ran a common grounding electroconductor underneath the panel and multiple disconnects, and then I tapped off of there with grounding electroconductor taps, and I went to ground rods, and there was nothing but ground rods. They wanted to argue that I had to use the 250.66 general rule, and it had to be larger. When at the end of the day, a ground rod can only take so much. That's the intent of 250.66a within the code language. That's why A is there. All right. So if you read it, and this is what it says down here, it has added the term bonding jumper, which is the proper term when you're connecting, let's say, a rod to a rod. If you're having to do the 25 ohms and you can't prove otherwise, you put 2 rods. If you can prove 25 ohms or less, you only need 1 rod, that application. Then the bonding jumper is what connects those together. And they do not have to be larger than what 250.66a is calling for here, which is no larger, not required to be larger than a 6 AWG copper or 4 AWG aluminum wire. I think it's important to understand that a 4 AWG aluminum wire can be done as long as you follow the rules in the code which say that it can be terminated within 18 inches of the earth, unless there is an actual listed device or fitting that can adequately accept that type of connection, and it's listed for that, and that's a whole nother topic. But it still can be done, and we still can use aluminum wire for that application. Running through the structure, no problem at all. So as you see here, it says the words or bonding jumper, which is to make it clear that you can connect multiple rods, pipe, or whatever together, that is still not required to be any larger than it states right here, a 6 copper. Keeping in mind that most of these electrodes on tests can't handle any more than what they can handle. And 6 to a rod, 6 to a plate, 6 to a pipe doesn't need to be any larger than that. Now, I have seen engineers, bless their heart, that will size something as large as a 4/0 copper, even a 500 kc mill to a ground rod, and have real no explanation of why they're doing it. They assume that it means that bigger is better. At the end of the day, the ground rod can only handle so much anyway, right? So it's like pulling 10 gallons of water in a 2-gallon bucket. It's not going to happen. But we have the provisions here. The important part of here is if I go from ground rod to ground rod to ground rod to ground rod, they don't have to be larger than a 6. That's it. If I go from rod to pipe, doesn't have to be larger than a 6 copper or 4 AW aluminum. Now, the significant importance of this, and this applies to all of them because I want to talk about them all in general, that even for concrete encased electrode, it's the same revision took place. They removed the sole connection. It's the same aspect where you're connecting one or multiple concrete encased electrodes together. That doesn't have to be larger than a 4 AWG copper. Doesn't give any provision here for aluminum, but it's 4 AWG copper. Now, this would probably be a proposal by somebody or public input in the 2020 edition to add aluminum here, but we'd have to do some work on where that connection be made, and I think we have. We allow that extension of that rebar to come above the earth. So basically, if it extended up 18 inches, why couldn't you make that connection with a properly listed fitting? But anyway, that has some work to be done. But anyway, you could do it. So there is really no change in these two, except for they removed the requirement for the sole connection. All right. And the same thing with the ground ring. Remove that sole connection. So here's the real good part about this is the misconception in the past when it came to things like daisy chaining. The grounding electrical conductor was the sole connection to the ground ring, the sole connection to the rods, pipe, or plates, or to the concrete encased electrode in accordance with 250.66 A, B, or C, had a provision for the size it had to be, and you didn't need to go to the table 250.66 to do the calculations for the conductors there. You didn't need it. In other words, I didn't need to go to this table right here and deal with that based on the largest ungrounded service entry conductor or equivalent area if they were parallel. So all of set A, for example, or B or C, whatever, that type. I didn't need to go here because I had the provisions that were provided for me back here. Okay. The importance of this is it made it clear is that, and here's the part you want to read. Here's the most important part. It says now let me go on and read it because it applies to all of them, but really take this in because there's been a lot of confusion on this sole connection language. If the grounding electrical conductor or bonding jumper, which is connecting multiple rods or plates or pipe electrodes together, to a single or multiple rod, pipe, or plate electrodes or any combination thereof, any of these together, as described in 250.52 A5 or A7, does not exist on the other types, does not extend to, let me read this again, does not extend on or to other types of electrodes that require a larger size conductor, the grounding electrical conductor shall not be required to be larger than 6. Okay, so let's break it down. If I go from a rod to a water pipe ground, then that's not going to work because the sole connection doesn't stop at the rod. It continues on to another electrode which requires a different size, and it's going to be a larger grounding electrode conductor than what you have here. Okay, so that's not going to work. That's not a proper daisy chain. But if I go from rod to rod to rod to maybe to a pipe, then they don't have to be larger than a 6 copper or 4 aluminum. That extent the same for the concrete encased electrode. If I run to a concrete cased electrode with a 4 AWG copper, but then I go from there onto a water pipe, then we have to remember that you cannot daisy chain in that method because it extends onto a larger an electrode that's going to require a larger size grounding electrode conductor. And at that point, that is typically not the sole connection. Since that has been removed, the code now says that it cannot extend to those other types of electrodes that are going to require a larger size conductor. So, very clear now what it meant to say before. I applaud Code Making Panel 5 for finally getting rid of the term sole connection and clarifying, saying, hey, we don't care if you go to electrode of the same type with the size that's required. But at any point you change from, let's say, these three here, you go to a ground rod, and you want to then jump from a ground rod to some other type of electrode that's going to require a larger conductor, you can't do that. The whole integrity of the actual path itself has to be established with the larger conductor. Okay? So, made it pretty clear, got rid of that sole connection thing, good move. Basically, the term for it was replaced with the text. Okay, so the sole connection really was talking about daisy chaining grounding electrodes with a properly sized bonding jumper, because that's what we have. If we go to two ground rods and we go to the first one, that's the grounding electrode conductor. If we go from that one to the next one, say 6 feet away, then that is a bonding jumper. Okay, so it's kind of clarified now the terms to make it easier to understand. The phrase or bonding jumper was added to each one of those subdivisions A, B, and C because it is correct terminology that kind of covered that, quote, daisy chaining occurrence that took place when you had multiple electrodes connected together. So I think if you read this one, you're going to be pleasantly surprised with the change. Again, do you have any questions on that? It's pretty simple. To me it is, but you know, hopefully everybody understands it. All right, let's go on to the next change, which is the 250.94A and B. This is dealing with the intersystem bonding terminations. This was another great change because I am in Texas and I dealt with the Northern Texas Electrical Advisory Board when I was a NEMA representative, and I argued where they wanted to use the actual intersystem bonding terminal device, which is designed, which stated that it was for communication systems. That's for CATV, TV, radio, telephone, NPBCS or PPBCS. All of those type non-powered broadband or powered broadband systems and all those applications could not, though they could use that intersystem bonding termination, but they argued that they wanted to be able to bring photovoltaic connections. They wanted to be able to bring the gas line for this, the corrugated type of, gosh, I can't even think of the name of it, and I've argued it for years. They wanted to make those, y'all know what I'm talking about. It'll come to me. I don't know, why in the world am I drawing a blank on that? Anyway, they wanted to make it very clear that that was not where you take other systems like the corrugated stainless steel tubing, the CSST. They wanted to bring that to this intersystem connection, and they actually passed something in Texas that all of the jurisdictions adopted. I tried to argue them and say that is not the intent. If you want something, if you want to have the ability to bring all those connections together to the grounding electrode system, then you need to provide for that. But it wasn't the intent of the intersystem bonding connection or the intersystem bonding terminal device, because many times they're only listed, okay, for communication applications like satellite, the satellites, the dish networks, all those type of things, in order to bring them all together so that the equal potential reduces crossover strikes, lightning, and things like that. And so that was what took place. And so here's what they did. They changed it and added to make sure that it was clear, because everybody was wrong when they said you could use that little device to do this. So they made it really clear for people to understand. It says communication systems. Okay? Communication systems bonding terminals shall be connected in accordance with A or B. All right, what does that mean, A or B? Well, A tells us it's the intersystem bonding terminal. It's specifically devoted, now called the IBT, for interconnecting conductors or bonding conductors dealing with the communication systems. And it covers all that information here. Now, If you want to bring other systems to this location, it can't be at this inter-system bonding terminal device that is listed for these communication devices. However, they did add something, you see the N, called other means. So let's say you don't want to do this. You don't want to use that listed device. I'm trying to go back here. You don't want to use this listed device that's listed for inter-system bonding terminals only. But you want to put an other device there, and you want to make these connections there. You want to make all of these connections for the CATV, cable, whatever. You want to do that? That's fine. You can do that. I would encourage against it because of noise and interference between the systems. But, you know, if you want to do that, under the other means, it says, look, all right, here's your other option. If you want to take an aluminum or copper bus bar that is not less than 1/4 inch thick, which is very familiar terminology, and 2 inches wide, and just like always when this provision comes in here, that it has of sufficient length to accommodate at least 3 terminations for communication systems, in addition to other connections, the bus bar shall be securely fastened and shall be installed in an accessible locations. Okay? Here's another important aspect of this new subsection here. It says, connections shall be made by a listed connector. If aluminum bus bars are used, the installation shall also comply with 250.64a. All right? So, it's not prohibiting aluminum. It's not prohibiting this application. Anything to do with that, it's saying, look, we're going to give you that ability to bring all those things, those other systems that you want, that CSST bonding, all that to a location. You can't use the communication, you can't use this device to do that because it has a specific desire, a specific need, okay? But you can use this other means, and as long as the bus bar meets the size and there's a sufficient length, it may have at least 3 terminals for the communication aspect, and then any additional terminal space available to meet the other aspects. No, I can't put one on top of the other and connect it to the same lug that the communication, because then that means that you didn't provide the adequate length for the 3 terminals for the communication in addition to the other connections. So you need an additional length in order to be able to make those independent connections. All right? So that was the significant. We gave you a bone here. You can do this. But that doesn't mean that you can go out and buy one of those listed inter-system bonding devices that is designed for communication, that's listed for communication, as expressed in the code. Again, as it's stated here, if you want to bring other things to that location, then you're going to have to use the other means application and make sure it's the right size bus bar, make sure you install it right, and make sure it has sufficient length to accommodate all the potential terminals that you want, and at least 3 for communications. The good news here, they did add an exception to the rule. The exception to both A and B, it says means for connecting inter-system bonding connectors are not required where communication systems are not likely to be used. So if you have a certain type of structure, that structure is a structure defined by the code, and the way it says that you have to have this type of connection for this inter-system bonding connection, you don't need it if there is an issue where you're not going to really require, or it's not likely to have the need for this type of system. I would not say that's the case on any commercial building or industrial building or a residential type building. But you might have a structure that is a tower, or you might have a structure that is something else that you can argue the point that you're not going to have these communication systems at, and you can actually use this exception and convince your local inspector of that unnecessary need for this type of connection. So you did get this exception in there to help you. This is a new exception for that. All right. Again, I want to remind you again, you are still prohibited from terminating CSST, photovoltaic, any of those other types of systems that are not communication systems to the inter-system bonding termination device. You have to use the other means and put a bus bar and follow these directions if you want to do that, if you want to bring it all in one. Doesn't mean you have to have both. If you only have communication, you can do the one device. If you want to have everything come to one location, then you got to do the other means. Okay. All right, let's move on to 250.102. There's been some changes here. And most notably, let's look here at, let me go back down. Bear with me. I want to get to the first part of it right here. All right, so this title has been changed because we knew that this table now, which was brought to us in the 2014, this was a new for the 2014. It kind of removed the use of the 250.66 for these applications because at that point it was limited only to the 3/0 or 250 is the max, I believe, for the grounding electrode conductor. And it had nothing to do with the grounding conductor and the bonding conductors, and you had to use it, and then you get into the notes, and it just became complicated. So everybody went to 250.102. It used to send you back to 250.66 for sizing. Now, in 2014, we have this illustrious table with very good instructions on how to deal with bonding conductors and jumpers and what have you, and grounding conductors. The only difference is that really in the well, the one big difference in the 2014 is that it didn't say grounded conductor here in the charge statement where the actual code was. It did say it in the table, okay, which kind of just was probably an oversight. It should have been here too. Well, we're always making those corrections. So it did apply, but now it just meets the way it was originated or the way it was intended, I guess. And so the term grounded conductor was added here because this is how you size the grounded conductor, okay? Of course, it always has got to be at least the size of the calculated neutral load, but here, or the grounded conductor load, but here it can't be smaller than table 250.102C1 as directed by code of 250.102C here. Okay? All right, so there's your table, there's your sizes, nothing really changed in that. That has any real significance other than it says here, see notes 1 and 2. 1 and 2 is talking about when it's over 750 aluminum, again 1100 kc mil, that you use a 12.5%, which is kind of what you got when we had to go all the way back to 250.66 prior to 2014. So that language is all here. Okay, so that's pretty much the language. What's the critical component that I want to add here is, let's go back to here. Look at these words here. Many people got confused when they read this and thought that only copper was corrosive resistant material. That is not the case. Aluminum and copper clad aluminum are very corrosion resistant materials. Very much so. In fact, they form a protective film on them that helps preserve them. So actually it's very self-preserving in those corrosive resistant locations. So, you know, a lot of people argue where armor or aluminum is exposed to a corrosive environment, they don't understand that the aluminum can form a protective barrier, and that protective barrier is very hard. That oxide, aluminum oxide, is very hard versus a copper oxide, which is very soft, which can be scraped off very easily. Not so with the aluminum. You have to work at it. So it's a protective, and so by adding aluminum and copper clad aluminum just reiterates the fact that even bonding jumpers can be of those type of materials, not just copper, and they are corrosive resistant material. Okay, that's kind of wanted to make that very clear of that application. So in the 2014 NEC, to size the grounded conductor, the main bonding jumper or system bonding jumpers or supply side bonding jumpers for an AC system, you would use 250.102 and of course table 250.102C1. That's where you would go. All right, but there again was no mention of for grounded conductor sizing except in the table title. So they just added it to the actual 250.102 language, and so that's really the key part there. We all knew that you used it based on the table's heading in the direction, because that's really what you had to use, because that's what 250.102 guided you to. So the other thing is to explicitly add aluminum and copper clad aluminum as the materials for acceptable bonding jumpers. It really harmonizes with the language that is found in 250.62 that recognizes aluminum and copper clad aluminum as a corrosion resistive material. Okay, many times people left wondering whether or not it was, and I can tell you, as a manufacturer or working for a manufacturer of aluminum and copper, that aluminum is very corrosive resistant in its application. Okay, so this change will help avoid any confusion. The other change that we have that I think that is significant to me is that we need to know that this also applies, all of this application right here applies to cables as well. So if I'm sizing, and this is under 250-102C2, when you're sizing parallel conductors installed in 2 or more raceways, but it also applies to cables. In the previous code it didn't say that and it left you guessing, but inside the language it talked about cables, so people didn't know what to do. So this actually was my proposal, kind of like a, just a touching it up and, helping it apply, so we added or cables. And I did this throughout the NEC. I had quite a few proposals on this. All it is kind of just bring it up to the to say what it says. One of those old things is that we want the code to say what it means, mean what it says, and that's what it says. All right, let's move on to the next significant change that we're going to deal with, and that is 250.122F. Most of you that are dealing with the code recognize that that's dealing with the equipment grounding conductors in 250.122. All right. So when we get down to that, let me get all the way down to F. Oops, bear with me. Oop, I'm only at 18. Bear with me. You got your code books. We have quite a few changes here in 250.122F. And let's look at it right here. It says conductors in parallel. So we're dealing when we have to run equipment grounded conductors in parallel. Now there has been problems through the years where you buy products like cables that are multi-conductor cables, like an NEC cable, and you have a single cable which was never originally designed to be a parallel application. Yet it can be done, but the equipment grounding conductor that's inside of that NEC cable, for example, is only sized based on the overcurrent protective device that would be protecting those conductors that are in that cable. If you ran them in parallel, obviously parallel together in accordance with 310.10 of the National Electrical Code, then it meant that it was going to be terminated together, connected together in parallel requirement at both ends to a larger overcurrent protective device that would have been intended if it was a single cable. Now there's 2. So when you were doing that, you had a problem because now the NEC cable, which you have to run in parallel, the equipment grounding conductors, were undersized, and they had to be full sized in each raceway or each cable system. Okay, so that was a conundrum that we had to deal with, and so that's still there, but it was a little bit hard to follow. So they did a great job. Kudos again to Code Making Panel 5 for kind of touching it up here and making it clear. Now one thing you will notice, there's ends here. There's an N on item 1, there's an N on item 2, and what it's trying to do is deal with conductors installed in raceways, auxiliary gutters, and cable trays. And then now we have direction when you're dealing with multi-conductor cables. Now these are pretty neat, so we got to kind of follow through each one of these so that you kind of get a grip of what we're talking about. Firstly, let's read the charging statement change here. It says, for circuits in parallel conductors as permitted in 310.10H, which is all the requirements for a parallel condition, same length, same characteristics, what have you, of each set, it says the equipment grounding conductors shall be installed in accordance with 1 or 2. So when you're in a parallel condition, you've got it, whether they're paralleled in raceways, whether they're paralleled in auxiliary gutters, which are a supplemental space to a piece of equipment, or cable trays. You have provisions for a single raceway or cable tray, or an application where these equipment grounded conductors are going to be run in multiple raceways. All right, so let's look at each one of them, since all of this is pretty much new information. Now, if I've got a single raceway or cable tray, so this is one raceway or one cable tray, it says if conductors are installed in parallel in the same raceway, so I might have parallel sets, but I have a larger, let's say a trade size 4 or a large cable tray, it says if all of them are in the same raceway or in the same cable tray, it says I can run a single wire type conductor as it shall be permitted as an equipment grounding conductor. The wire type, okay, the wire type equipment grounding conductor shall be sized in accordance with 250.122, again, based on the overcurrent protective device for the feeder or branch circuit. Okay. Now, like it was before, since we're talking about parallels for a single and you bring them together, they're going to be constituting one circuit, then we need to know what that overcurrent protective device is to protect that circuit. So we would run that equipment grounding conductor to protect that circuit. And remember, we're talking about a single raceway or single cable tray where the conductors being run in parallel are in that cable tray or a single raceway. Okay? It says wire type equipment grounding conductors installed in cable trays, because first one was raceways, in cable trays shall meet the minimum requirements of 392.10b1c. Okay, so you have your requirements there that have to be met. Okay, now it says metal raceways or auxiliary gutters in accordance with 250.118. That is where they qualify as an equipment grounding conductor as in themselves. Okay, or even a cable tray that might qualify in its construction and in its listing in accordance with 392.60b shall be permitted as the equipment grounding conductor. Okay, so it's not prohibiting you from running a wire type equipment grounding conductor, encouraging it. Many engineers do encourage it. However, the code is saying, look, we're also going to recognize that the raceway, the cable tray, or the auxiliary gutter, as specified in 250.118, or if it's a listed product like in 392.60b, then we're going to let you use that as the equipment grounding conductor when we're dealing with the paralleling of a single raceway or cable tray for this application where you have parallel conductors run in it. Okay, we're going to let you do that. Okay, and that is pretty consistent. We don't have an issue with that. Okay, as long as it qualifies under 250.118. All right, now what if I have multiple raceways? We're no longer on the single raceway. What if I have to have multiple raceways in order to be able to run my multiple parallel conductors? It says if conductors are installed in parallel in multiple raceways, wire type equipment grounding conductors where used, okay, again, if they're metal raceways, you do have some provisions up here. You're going to see that it's going to be pretty similar, but it's where they're used. It says shall be installed in parallel in each raceway. Again, legacy from 214, that's not changing. It's got to be run full size parallel in each raceway. Now, it says the equipment grounding conductor installed in each of those raceways shall be sized in compliance with 250.122 based on the overcurrent protective device for the feeder or branch circuit. Okay, so look, there's no paralleling here and reducing the size and whatnot here. They're going to be full sized. They're going to be in each raceway. Okay, and that's the provision here. Now it goes on to say, look, I am reminding you again that if it is a metal raceway, a metal auxiliary gutter, in accordance with 250.118, then it qualifies as an equipment grounding conductor and you don't need to do what we just talked about. Or if it's a cable tray that is listed and identified for use in 392.60a as an equipment grounding conductor and it meets all those provisions as such, as we see here, then it can also be considered an equipment grounding conductor as well, and you'll be in compliance. All right? That's pretty simple, broken down pretty easy to understand. You only have to identify whether or not it's a single raceway or a multiple raceways when you're needing to run those parallel applications. Now we got the new one here, which I am excited about. Some of it's a little bit wondering how you might achieve it, but I'm not here to discuss that. You're going to have to work with your with your local firm and how you're going to achieve this. But multi-conductor cables, first law, let's look at A. It says if multi-conductor cables, and when I say multi-conductor cables, I'm talking about MC cable, tray cable, SE cable, all of those are multi-conductor cables. It says if multi-conductor cables are installed in parallel, as they're permitted to do, it says the equipment grounding conductor in each cable shall be connected in parallel. Okay? Again, once you get to that location, you bring them together. They have to meet the parallel requirements that we saw previously, that we saw the base rule in 310.10h. So that's nothing new for that aspect of it. Now, B comes into play. It says if the multi-conductor cables are installed in parallel in the same raceway. Okay, so now we're just talking about multi-conductor cables installed in a raceway, auxiliary gutter, or a cable tray. It is telling us that a single equipment grounding conductor that is sized in accordance with 250.122, again, shall be permitted. Okay, shall be permitted in combination with the equipment grounding conductors provided within the multi-conductor cables and shall all be connected together. So what this provision is doing is saying, look, we understand that there's MC cables that are on the market, whereas if you put them in parallel, the equipment grounding conductor is going to be undersized based on that parallel project. We're going to let you use that markedly available MC cable, even though we know that equipment grounding conductor is sized proper for that individual cable itself, but not in a parallel application, but they're widely available on the market. We're going to let you do that provided that you run a properly sized for that parallel application based on 250.122 overcurrent protected device, and you size that equipment grounded conductor and you bring them all together in order to create a in facto parallel application. Then we know that in the event of a fault current, we do have an adequate path regardless of the undersized based on each separate cable. This is throwing a bone to us manufacturers saying, look, continue to produce your MC cables with a equipment grounding conductor that is sized based on what would traditionally be protecting those conductors. So now you're running them in parallel. You don't have to increase your equipment grounding conductor for that potential purpose. Now you could, if you wanted, you can have a special brand. You can create what's called a paralleled MC product and just creates another SKU you got to worry about. Or you have this provision. Now, let's understand that only this provisions are going to allow that. If I still want to run two MC cables in a parallel application that doesn't meet this requirements here, all right, that they're not run in the same raceway, auxiliary gutter, or a cable tray, then I'm going to have full-size equipment grounding conductors, and that's going to be a special type product that has to be made from the manufacturer for that properly sized equipment grounding conductor. So this gives you some ability here, depending on your application, whether or not you're installing them in a cable tray, in a raceway, an auxiliary gutter. This does give you some leeway here. Now, it goes on to bring into another one here. It says C. It says equipment grounding conductors installed in cable trays. Okay, so it's bringing some more info here. Remember, we're still talking about multi-conductor cables. It says equipment grounding conductors installed in cable trays shall meet the minimum requirements of 392.10b1c. Cable trays complying with 392.60b, metal raceways in accordance with 250.118, or auxiliary gutters shall be permitted as the equipment grounding conductor. Again, they're saying, look, if you meet the requirements for that cable tray, in order to be considered an equipment grounding conductor, it's listed for that application. It meets the requirements as such for metal raceways under 250.118, like an EMT, rigid metal, those type of applications, then it is okay. It is adequate. You don't need to run the separate one. Okay? So we have some provisions here to do that. But you have to meet the minimum requirements of 392.b1c. Jot that down, go look at it. We don't have the time to go into every aspect of the code because this is just a change class. But you have to understand that it has to meet these minimum requirements. So I encourage you to write that down and go look at it. Now, except as provided in 250.102 F2B, which is F2B right here, this one. Okay, unless you meet this is what it's saying is, look, like what I just said earlier, if you accept here where it gives you a bone, it says for raceways or cable tray installation, the equipment grounding conductor in each multi-conductor cable shall be sized in accordance with 250.122 based on the overcurrent protected device for the feeder or branch circuit. So again, if you don't meet this provision right here, then it's just like I said earlier, you're going to have to make sure the MC cable or other multi-conductor cable that you purchase is going to have a full-sized equipment grounding conductor for that parallel intent. Okay, you can't use an off-the-shelf. You understand what I'm saying here? Hopefully you get it. That's what it says here. It says, hey, I'll let you do this. But if you don't do it this way, don't forget that whether I run it in a raceway or a cable tray in a parallel application, if I run multi-conductor cables in it, you're going to make sure that equipment grounding conductor is sized properly. If they're running parallel, and that overcurrent protection device is going to be obviously larger to protect that parallel application than it would have if it was a single cable, then you're going to have to size that equipment grounding conductor full size. All right, I beat that one to death, man. You all out there should be de facto experts on that now and be able to convey what in the world we're talking about. We threw a bone out there, I guess, to the cable tray people, not the cable tray manufacturers and whatnot. So obviously if they get more of their products listed, good for them. All right, let's move on. Let's see. Again, the rationale was running a separate equipment grounding conductor in a raceway, auxiliary gutter, or cable tray will provide an adequate fault current path while allowing the use of a commercially available cable wiring method. Like I said, we make MC cable with the equipment grounding conductor based on the requirements of UL 1569 and based on the perceived overcurrent protected device to be utilized with the conductors that are in that cable. Not for when you run it in parallel, because all of those factors change. Can you order them specially for that? Yep. It is not an off-the-shelf thing, I can promise you. All right, next one we're going to look at is 250.148. This is the continuity and attachment of equipment grounding conductors to boxes. So let's go to 250.148 and look at that change. And we're getting close to the end, so hang in there with me. If you zoned out on me, we're getting close to the series end, so it doesn't look like we're going to go more than about an hour and 30 minutes, so that is great. Hopefully you've written all this down, all these changes, so you can go look back. Hey, I'm a student of the code, but I'm a student of the current code. I don't necessarily always go back and look at what's in the 1965 code, even though I have a copy of it. But you need to have your code book. You need to get the latest edition. You need to be able to go back and look at these different changes and kind of absorb them in a little more detail. Or you could send me a question and we'll answer your questions and try to get you the answers that you need. All right, so this is a revision to 250.148 dealing with the continuity and attachment of equipment grounding conductors to boxes. To paraphrase this, it says, well, you know, rather than paraphrase, let's just read the portion that I'm going to read here. It says, if circuit conductors are spliced within a box or terminated on equipment within or supported by a box, this is important, all equipment grounding conductors associated with any of the circuit's conductors shall be connected within the box or to the box with the device suitable for the use in accordance with 250.8. So 250.8 has been added to remind you of the proper terminations that have to be used. They give you guidance on terminations, so that was added in the 2017 to give you that guidance on where to go and say, yeah, okay, I understand you want me to make all these together, but give me some guidance on the terminations. Well, it does now, so that's great. I think we knew that as code users, but it's always great when the code elaborates a little bit and gives us some direction. That's why I'm a big fan of informational notes, knowing that they're really just guideposts through the code. And I know we don't want a thicker code, but I can tell you I am all for more informational notes. When anything seems confusing, it does tend to add clarity. All right. And the reason it adds clarity is because we know they're not enforceable. They're just information. And that's a great thing. I like an informative document. All right, so let's what this is, let's get to the core of this. This revision clarifies that all equipment grounding conductors that are associated with any of the circuits that come to that box must be connected together. There were many times where we saw people send me emails or question. I had inspectors call me and says, wait a minute, I'm in a kitchen and they've got a 14 gauge coming in for the lighting and they got a 12 gauge for the kitchen circuits, and they isolated them away. And I would say, look, the whole purpose of the system, the whole purpose of tying it together to create that low impedance fault current path is to connect the system together so that we have that one path. So the code here is saying, look, it doesn't matter whether it's a 14 gauge or a 12 gauge, if they're in the same box, they have to come together to create that system. That's what it's saying here. It's also reminding us that, look, there are some provisions where you don't need to do that, where you have isolated grounds. It still gives you that leeway for that in the exception, okay? it still gives you those leeways in 250.146D where they're isolated pieces of equipment. We get that. It's all still there. We understand some of the direction there for the isolated ground circuits and for existing applications. But the real intent here was to remind you that we need to make all these connections together. And that was the intent here that had to take place. So we need those EGCs, if you will, to commingle. Right? And people used to think that you did not, that you kept them separate for some reason. Remember, current only travels on that equipment grounded conductor in issue where you have a ground fault condition or one of the conductors fault out to something that is grounded, and that provides that path in order to allow the overcurrent protected device to recognize that sudden increase in current, and based on the rating of that overcurrent device, which can range from anywhere between 6 to 8 times its rating, allows that current to surge and allows that overcurrent protected device inversely or infuses or whatnot to activate and clear that circuit. So it's very important to provide those paths. All right. The next one we're going to look at is 250.187B. And this, to be honest with you, this is dealing with grounding of systems and circuits over 1,000 volts. In my career, I have not dealt a lot with these type of systems. So, I am not generally an overt expert in these, except for to be able to tell you the code rules behind it. And then I can tell you that. So the change here that took place for this one is the neutral conductor. Now this is when you're dealing with a impedance device, okay? And so here's the change. It says identification and insulated. It says the neutral conductor shall comply with both of the followings. Now, the neutral conductor shall be identified. Now, I want to go back down and let you see, what we're talking about here, and that is dealing with impedance grounded neutral systems, okay? These are systems that aren't directly solidly connected to Earth. However, they create a reference due to an impedance device like a resistor. And it can be a high resistor or a low resistor, low impedance, higher impedance, depending on the size of the resistor. Obviously constitutes which system we're dealing with. It's trying to give you some of the benefits of a system that is theoretically ungrounded but gives you this resistance. But it's called an impedance ground neutral system. And basically the change here is saying, okay, the neutral conductor shall be identified, so we have to identify it. I'm good with that. Then it says the neutral conductor shall be insulated for the maximum neutral voltage. That's what it's stating. The maximum neutral voltage, that is the voltage, rather, it is between the phase conductors applications. So many of the medium voltage systems that operate in 2.4 to 15,000 volt ranges are either a low resistance ground or they're a high resistance ground. Really the only difference in those is the value of the resistor, okay? And it controls the amount of ground fault current that's permitted during a ground fault event. So it kind of controls the amount. And the only other common one is what's called a solidly grounded system, which is the more common when you're dealing with medium voltages above 15 kV. They're typically going to be solid grounded, or they're going to be just de facto ungrounded type systems, okay? The fine print note, excuse me, did I actually say that? The informational note that is added is significant to understanding if you're the electrician that's used to dealing with things like 2400 volt systems or 4160 volt systems or even higher, larger voltage systems. When you're dealing with it says that it's 57.5% is the maximum neutral voltage three-phase for a Y system. It's between phase-to-phase voltage. So example, if I had a 4160 volt system, 57.7% of the phase-to-phase voltage equals 2400 volts. So I have to make sure that my insulation is rated for 2400 volts, okay? That application. It's also important to understand that this is very true for a three-phase Y system only, okay? So you really have to coordinate with the engineering firm that is doing this calculation or dealing with this to really meet this and understand that that neutral conductor shall be identified, which is pretty easy. We understand how to identify the neutral conductor in this case. But we also have to make sure that it is insulated for the maximum neutral voltage here. Okay? And again, the informational note adds clarity to what we're talking about when it comes to magnitude of neutral voltage here. All right. All right, so I believe that's it for those. So what I'm going to do is bring me back into the equation and say, look, I want to thank you for taking the time to actually watch this video. I want to thank you for taking the time and going over these changes, because these are pretty important changes. Now, of course, we can't cover every change in this session, but we did cover more of the significant when we're dealing with the grounding electrode system. We understand the new aspects of in-ground systems, supporting structures that are going to be used as an electrode. We understand a little clearer that the water pipe and the metal framing of a building is the real issue is the extending, not the 5 foot in and back 10 feet in the earth for the water pipe to be an electrode, but we're talking about the portions that are actually extending the connection or being used as a conductor in 250.68 C1 and 2. We're learning those, and we're understanding the expansion here. This all started in 14. So there's a lot of things that we covered today. That sole connection is gone. We now understand it in clear terms in the code. We made a great improvement in explaining that process of the daisy chaining, which can be done now if there are the same type. Now, still can be daisy chained if they're not the same type, except you just can't use the allowances in 250.66 A, B, or C for that application. Okay, so it added clarity to how we apply it. That was the key thing. So hopefully you got something out of it. Again, visit the website, electricalcodeacademy.com, .org or .net for that matter. The emails come to info@electricalcodeacademy.com. It has to come to the .com. Or it can come to info@masterthenec.com. Visit our website. Visit us on Twitter. Love to see you on Twitter. Love to follow you. Click and follow us. We'll follow you back. It's @MasterTheNEC because that's the name of this series. You can also follow us on Facebook. Just go to our website. At the bottom right of the screen, you'll actually see the icon for Facebook. Go to our Facebook page, join, chime in. But more importantly, visit our web message board and get an account. You can read it for free, but get an account and chime in. I learn something new every day. I can tell you what, the National Electrical Code is an amazing document. I have made a career with it. I read it almost every day, multiple times a day. Not because I read something that I don't know. It's because I like to look at it and get a new perspective every time I read it. Not that it's part of my job, what I do every day. But again, I for years have done these things at no charge, just to try to help educate others. And if I can educate one person out there, hey, I'm happy. If I can help you pass a test, if I can help you watch one of my exam prep videos that helps you pass that test, that means the world to me. I like to see other people succeed, and it's important to me to see that you succeed. So again, reach out to me at any time. If you're an inspector, you're an installer, you're an electrician, you're a journeyman, keep studying. If you're an apprentice, keep at it, become a journeyman. One day you'll be a master. Get your license, take as many tests as you can, build your knowledge, pass our website on, pass our videos on, and hopefully we taught you something. God bless. Until next time, thanks for watching. And again, I hope that you really get your code book, so get your 2017 NEC, and really start to learn these changes within the National Electrical Code. Thanks again. God bless.